All right, hi guys. So first, I apologize for not being there today. Of all lessons, I don't want to start a new unit out, but I had a kid at home sick, and I just couldn't come in. So um, today, what we're gonna do is we're trying to learn more about taking a sample and applying it to the whole population to see if it's applicable or to see what the real population stats say. So for example, we're talking about global warming in this example, and we poll this many people, this 1501 number. Okay. Now, 70% said they do believe in global warming. Now, I'm not trying to be controversial or not here. Whatever you think on the topic's fine. But I'm just saying, okay, so we have a group of people. So it's like a group of people out of the entire population. If the box is the population and that circle is the sample, right? Obviously, it's just a small subset of what could be in that box. Now it says find the best point estimate. All that means is we're going to find a number that's the best way to talk about the population. So more often than not, we talk about the mean, okay, and how do we estimate that and so forth. So let's go this. Let's gonna go to the next board so we can see the next slide. Sorry, it's just being a little finicky today. Okay, come on. Now this is me being impatient. All right. So, like that picture I just drew, now, of course, my board two, okay, was the same thing that I just drew, okay, and it just happened to be the same thing. So, let's take a look at example three, board three. So, if I gave you this selection of test grades, what would you say? Right? I have some really, really lows. I have some really highs though. So I can't say the class did very well or very poorly. So I'd end up having to take an average. And this sample size, well, does that say everything? So, like, if this is my period three, my period four algebra two, right? Does that say everything about all algebra two students, or does that say more about period four? Well, we can then kind of determine that. All right. So let's move on to slide four. Okay. So, couple vocab, couple notation things. Something to point out. If we're talking about the population, we're going to use P for population, and this thing with the arrow, it's kind of cut off. It's read as P hat, right? It's just the variable that represents the small subgroup. So in this case, right, in this global warming example, P hat is equal to 0.70 because 70% said yes, they do believe in global warming. Okay, so a little bit of notation as we start working our way towards the actual problems. So let me get the next board up. So next board is board five. Okay, so if we take a look, all right, we want to be able to say as much info as we can about this mean, about this population. And we use these things called confidence intervals. Okay. So we can say with confidence where the mean will sit. So we're going to create a range of numbers. We're going to basically say, hey, our real population is going to fall between two numbers. Maybe 60% and 80% said, yeah, they do believe in global warming, right? I just made those numbers up. We're going to calculate those later. However, so these confidence intervals, okay, are ranges of values, meaning low number to the high number, where this true value. Now, notice when I wrote this up here, which I wish I didn't scribble out now, I used the letter P. I didn't use P hat. I said, hey, the population mean or the proportion of population. So the actual, if I sampled every single person in the world, they said yes or no, they would sit between this low number and high number. Okay, so let's keep going. All right. Now we can use different. We can use different numbers. Oh, sorry. We can use different numbers to represent how confident we want to be. If we're okay with if we're okay being 90% confident or 95% confident, or sometimes we want to be super, super accurate, okay, we can use these different numbers. And so if we take a look, all right, in this case, if 90% confident gives us a 10% fail, that it's going to fail. In this case, it's 5% going to fail. and 1%. I don't know why my pad is starting to not work, but 1% is going to fail. Now, how we know this, how I just came up with this was okay, um, probability, my probability is equal to 1 minus, and this fancy letter is called alpha, and that alpha is the chance that it fails. Okay, so I'll get into what these numbers are going to do and all of that. However, just understand more notation, and there are different levels of accuracy. Basically, is what we're trying to get at with that slide. Okay, so let me scroll down. All right. Next one. So we're going to learn how to calculate them in the next video. However, it's important that we're able to talk about them and read them. So let me scroll up. Okay. So we went back to the population proportion, the sample proportion, I should say, was 70%. I want to be 95% confident that we know where the population proportion is. Okay. So in this case, we did the problem and this is the answer we get. This right here is perfectly how to read that confidence interval. We use 95% confidence. So we are 95% confident that the population proportion, the number of people who said yes, or the percentage of people that said yes, they believe in global warming, sits between 67.7% and 72.3%. That is how you read this. Okay. And then that's different. Then let me find how not to read it. Okay. Sorry about that. This is trying to do a PowerPoint on this video is a little bit trickier than just my normal notes. All right. So, how not to read it. Okay. There's not a 95% chance that it falls between those numbers. Okay. It's 95% sure or confident that it sits in there. It's not saying 95% of the time because sometimes it might be lower or higher. However, we are 95% sure that it sits in there. It's not a 95% probability chance. Okay. So that's just something to clarify there. All right. Couple more. Now, how the heck do we start to kind of build that low and high number? Okay. And the good news is that it's similar to what we've been doing. Okay. We're going to have, if we take a look, these numbers down here at the walls, we had been calling Z's. Okay. However, first we need to know where this wall and this wall are. And those are what we call critical values. Okay. And those critical values, okay, are based on that inverse normal button. So if we take a look, oh, and now of course I didn't realize it was going to erase my picture. Okay. We have to figure out, hey, what's the chance that it fails? And the problem will tell you 90% or 95% or 99%, and then divided by 2. And now when you divide it by 2, it's going to give you the area that's in that red section. So for example, if I want to go 95% confident, I know my 5% fail. Okay. So the total of red is 5%. Well, if I divide 5, and this is alpha, if I divide it by 2, well, each section then is worth 2.5 and 2.5%. Okay, so the next slide is going to show you actually how the actual decimals and all of that. So let's see. Okay, so again, we have the 5% because this is given to us. We divide it by 2 to get 2.5. Here is the percentage that sits in the red curves. I think honestly, it's easier to do inverse normal, and we can do it over here to this one. So if I go 0.025, because that's the percentage that's to the left of my wall, right? It's going to spit out negative 1.95 blah, 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 which can round to this. Now, it's always just going to be the plus and minus version of that number. So these are important because that's going to be played in our big formula, which is coming next. Okay, and then the last slide in this video. All right, let me scroll down. Is just, I believe it's just showing you one more time of that. So now we will use the plus and minus in that formula, which is coming up next. So a little bit of confidence interval intro, a little bit of notation, examples coming soon. All right, thanks guys.